forecasting. When we know what is the output, so usually we use T method. And there are another two classification technique using MTS, MT method and RT method when the real value is unknown. So most of our group member in UTM for prediction, now we are using T method for prediction because we know the output. For example, if I want to predict the process parameter for machining, I know I have data pertaining to metal removal rate because the function of the machining is to remove the material. So the parameters could be depth of cut, cutting speed, feed rate, spindle speed, and so on. So when we have those data with the output that we know, the metal removal rate, because the function of the machining process is to remove material. So using the method with the output that we know, we want to know what are the parameters possibly for example, inconel material. So we can do the prediction using T method. For instance, if we have the characteristic of something, and the function of the brake system is to stop the car. It's not immediately stop the car, otherwise the passenger will hit the windscreen. So we want to stop the car when it should stop. So that is the output. That is an example of output that we know. And how about the new era, where we talk about digitalization? In Japan, we have digital, I forget the terms that been mentioned by my colleague yesterday. But in Malaysia, we have industry forward. Industry forward is a policy to digitalize our industry, especially the manufacturing industry. So in the new era, people are talking about Industry 4.0. So this morning, I would like to share with you what is Industry 4.0. So I would like to begin with Industry 1.0. If you remember, during those days, in Industry 1.0, everything was powered by steam. We have locomotive, then they have to heat up the boiler to power the locomotive. And most factories are using boilers those days to rotate the actuator, to move the actuators. But when industries invented electrical system, for example, motorized motor, which driven by electric power, so we start to have localized automation. And we start to be introduced with the mass production. But in Industry 2.0, although it is localized automation, but there are some of them already digitized. So what I want to say here is, if the factory, the automation level is localized and not connected to the internet, they are Industry 2.0. In Malaysia, we are stuck with Industry 2.0, especially the small medium enterprise. But there are multinational companies, especially semiconductor, and also GLC, government linked company. They have good capability in terms of capital. So some of them are already connected to the internet. But that's Industry 3.0. When we have global production, for example, there are companies in Malaysia where they do the design, the product development in Malaysia, but the manufacturing is in China. For example, there is one company, we call it Schinkel. The name of the company is Schinkel. It's a Malaysian company, not German company, but they use German name for the marketing purpose, I think. So they produce refrigerator for hospital purpose to keep the dead body in the hospital. And then the design is done in Malaysia, but the manufacturing line is in China. Similar to Apple, Airbus, Boeing, and so on. Because they have internet. So data will be transferred, the CAD/CAM data, computer aided manufacturing data will be transferred to the factory abroad. And then the machine, the CNC machine and whatever machine will do the process. And then, because in Malaysia, there is an agreement, bilateral agreement between China and Malaysia. So everything imported from China is tax-free. So it's like we are doing it here because the limitation here, we do not have the raw material. So we have to import the raw material in US dollar. So that makes the price, the cost higher. So that's industry 3.0. The big company can afford for that, but not the industry, small medium enterprise. In our country, we have around 90% of SME contributes to the gross domestic product. Then what is industry 4.0? Of course, they have internet, but they are equipped with the cyber physical system. Cyber physical system is the artificial intelligence, cloud computing. You can Google in the internet what are the cyber physical system. And with the help of the internet, they have a capability for horizontal and vertical integration. Means machines can communicate. Machine can transfer the data, can continue the process, and the data will be transferred to the cloud computing, and then cloud will transfer data to the machine in the real time in two-way communication. They communicate in multidimensional in the real time with less human intervention. Human is still needed because with a human brain, it's needed to teach the machine. The artificial intelligence will be will have no capability until human teach them, because God gifted brain is more powerful than the artificial intelligence. So there's no issue that human will losing job because of the artificial intelligence. So that is industry 4.0. And sorry, I think your battery. Okay. So if I can share this slide, many companies, they have raw data. Whether they convert the data into information or not, it depends. Especially the small medium enterprise. So if they manage to convert the data into chart, for example, whatever available in the Power BI, now Excel also link with the Power BI. We can use Excel to get the Power BI facilities. So with that, we know what is happening in the factory. We know what is happening. But when we keep the data in the server, many data, then it will help us on the descriptive. So with descriptive, we know where and how does it happen. I'm giving example. Our colleague, Tessima-san. He worked with the Japanese government to predict the earthquake. So with the data, what kind of data? The frequency of soil, movement frequency, the weather data, and all data related to the geographical of the area. So with the data that been collected for so many years. So with the descriptive analytics, it will help to tell the government where the earthquake happening and how it's happened because of the soil structure or whatever. And that's CPS, Cyber Physical System level 1. When we have more data and we have better algorithm, it will help us on the diagnostic analytics. With diagnostic, there is CPS level 2. It will tell us why does it happen, why we have an earthquake, or maybe there's a vibration somewhere else that cause earthquake in uh, the Hokkaido, for example. And then if we go further to the CPS level 3 and level 4, that's predictive analytics. We know what will happen and when it's happened. Oh, the earthquake will going to happen next week or next 2 weeks or next month. So that's the predictive with the artificial intelligence. And we can use the T method as well for this predictive. And the highest level is CPS level 5, when we know what to do when it's happened. Evacuate the area before earthquake happening. So that's CPS level 5. So if we were to relate with the plant, with the factory, for example, we have pump to give energy to the fluid, to the liquid in the factory. So we can use this for conditioning monitoring. We put sensor, vibration sensor, for instance, temperature sensor, to measure the variables, the control factor of the pump. And with the data that we have, we can predict when we should do the preventive and corrective maintenance. We know when the bearing is going to wear. So we have to plan for the replacement of the bearing, for example. We can plan because we measure the temperature of the bearing journal bearing, so we know when we should do the oiling. And then plant shutdown and so on. So because we are at level CPS level 5. So we can use that for conditioning monitoring as well. And yesterday, keynote speech given by Engineer Shin Taguchi. If you remember on the IDOV, the first one was Global Voice Customer and Future Voice of Customer. This is quite crucial for the business, especially whether it is service or product development industry, to know the S-curve of the product development, when it's mature, when people are excited to buy the product. So with prediction using artificial intelligence, we have natural language processing, and the subset of the natural language processing is a sentiment analysis to know what are the sentiment of the customers. Sentiment analysis will evaluate the emotional tone behind the series of words gained from the attitudes of customer, opinion, emotion expressed by the customer, probably from social media or customer feedback and so on. In Malaysia, we are good on the sentiment analysis for politics especially. The government know whether they are going to lose their election or not. They know what are the sentiment that they can use to attract the voters. What the young voters like, what are the preference of young voters, what are the preference for the middle-aged voters and so on. So in business, we can use this artificial intelligence to understand the sentiment of their customers, because we want to know why they are so interested with their competitors. For example, Android, we have Android and iPhone. Why young generation prefer to use iPhone, even although the iPhone is not designed for the young generation, it's designed for professionals. So that's a sentiment that the Android phone makers should understand the voice of customers among the phone users, because they want to attract the iPhone users to Android, for example. And in order to have that, we should have the natural language processing, because sentiment analysis is under a subset of this NLP. What is NLP? NLP is the enables machine to understand and interpret human or spoken language or written language, and shift to through customer feedback across various platforms, social media, comments, customer support transcript, online review, and so on. And in order to understand the voice of customer, we can use also predictive analytics. What is predictive analytics? It employs statistical model and machine learning algorithm to analyze historic and current voice of customer data to forecast future customer behavior, needs, and trend. It's like a crystal ball for business. Oh, crystal ball, what is the customer need, voice of customer for next 10 years about a car? How about what is the styling they like? So we can use this predictive analytics. And then in order to understand the voice of customer, there is automated learning. What is automated learning? To analyze pattern and trends within voice of customer data, AI system learn over time that customer value, their pain point, and how they interact with the product or service. So this intelligent analysis allow business to address concern in the real time. So when the data in 4.0, talking about for industry 4.0, the data is transferred to the cloud in the real time, in multiple dimensional. So it enables the business to do the real-time prediction about their voice of customer. So we don't have to do customer survey anymore, because we already have this kind of tool. Okay, so what is our work we are doing in UTM Taguchi Center? So I would like to share what our researchers are doing. Zulkifli Marla, I think he has presented yesterday. He worked with the boundary bet algorithm for the T method. So we use this for prediction, but we try to fusion the MTS, the Dr. Genichi Taguchi knowledge with orthogonal array, monopoly distance, with the machine learning algorithm. And then this is about his work, integrate normalization-based boundary bet algorithm with the T method as variable selection approach to improve the T method prediction model accuracy. We want to increase the mean absolute error, MAE. And this is an example. He compared T method with OA and T method with bet algorithm. And for the preliminary work, it shows the reduction rate for the variables all about the same, but it managed to increase the efficiency better for the mean absolute error. And this is work done by Dr. Nolia on the hybrid bootstrap-based algorithm with binary artificial bee colony and particle swarm optimization in Taguchi method. This is what she's doing. These are the problem statement. And then her objective, design mechanism to determine accuracy unit space, formulate mathematical model, and then develop architecture, feature selection using hybrid bee and particle swarm. And he validate the accuracy of the algorithm. This is about bee algorithm. There are a lot of number of publication on the bee algorithm in the journals. And then this is the conclusion. She managed to achieve all the objective. And this is another work by our team member, on prediction of the bus traveling time. So we want to predict because we want to know in the real time what time the bus will arrive. Because usually the scheduled bus timetable is not accurate. So with the artificial intelligence, it will help the bus operator and the customers to be on time at the bus stop. So she used T method as well for the bus prediction. He limited the case study to route in Kuala Lumpur from KLCC to Ampang as a case study. So after that, she will generalize. It will help the infrastructure authority to generalize the application. And then one of our PhD candidates, she will present after this today on the handling missing data in Malabis technology system using random forest algorithm. So she used random forest algorithm to enhance the capability of the T method on forecasting. And this is her objective and problem statement significant. And she used a liver disease data set for her preliminary study. That's all from me. So what we can conclude is that using artificial intelligence with MTS can make prediction much accurate and reliable because we vision the benefits or the strength of the MTS T method with the artificial intelligence, machine learning, so that we can introduce this knowledge to the artificial intelligence researcher to make them appreciate on our method, MTS, T method, and so on. Flexible and work well with different types of data and prediction tasks. It's adaptable to various industries and applications. We believe from one of our students on the bus time traveling time prediction and some of the service case study using the data. So we hope that this T method we fusion with the artificial intelligence machine learning algorithm can be used in many applications, whether it is manufacturing, design, or services. Combining AI with MTS opens new possibilities for future investment in prediction. So this work is supported by Ministry of Higher Education research grant. Thank you very much.
Okay, thank you, Prof. Rika, for the nice presentation. So I think I open for the Q&A.
Yeah, please.
Yeah, I think some people are talking right in Industry 4.0.
Yes.
Also, they're recommending to improve data quality aspects, data quality.
Yeah.
And number two is the managing risk, like risk management is important.
Yes, yes.
So you guys are considering those aspects.
Yes, yes, we're concerned about that. Because in the cyber physical system, one component in the cyber physical system is data security. And when we assess the industries, they are concerned, especially the small medium enterprise who are dealing with product development, because many of our SMEs, they are exporting 80% to 90% of their produce, they export abroad, especially SMEs that owned by Chinese businessmen. They export to Norway, they export to Australia. So they are quite concerned about this because when we talk about Industry 4.0, the data will be transferred to the server. and to have their own server in-house is cost for the maintenance of the server and also for the data storage. So I quite surprised when people are talking about to have bachelor in artificial intelligence in their university in Malaysia, because the cost for server alone cost them around 3 million ringgit per year for the server. And we cannot delete the data when we keep the data. It's useless because when you keep data, then you delete data. You know, in Malaysia, we have AirAsia. AirAsia, they started their business since 1990s. They introduced online ticketing. And everybody were happy because they can get the plane ticket around 10 ringgit. But 10 ringgit is not actual price actually. The actual price is 200 ringgit. But there is sponsored by the AirAsia because they want to buy the customer data. Similarly to the Facebook, Instagram, Twitter, or whatever. That's why if you open your Facebook account and you compare with my Facebook account, the advertisement will be different. So Asia already learned their customer behavior since they start their business. So during COVID, they know what to do. So you imagine how many years they kept the data and how big the storage they have rented from the cloud server provider. So to answer your question, is our concern, and the risk is the cyber attack. Yeah, in Malaysia we have the cyber security Malaysia that will oversee that. Okay. Any other question?
Okay, any more questions on the floor? Yeah, Jason, yeah, Jason.
So, thanks so much for interesting topics. So,
Okay.
my question is in the background topics, which is yes, industry 4.0.
Yeah.
Maybe so in Japan, so society, my point.
Yeah.
And my question is related to before industry 40%. And what do you see is a lot of policy methods, effectiveness of policy method in industry 4.0?
Okay, thank you.
So just a little bit big question first. Sorry. I want to answer your ideas.
Okay, thank you. Okay, to answer the question about Takuji method we use in the IDDOV, actually, if we were to relate with the Industry 4.0, especially at the I side on the voice of customer, because as I explained earlier that we can use artificial intelligence to get the real-time voice of customer. So what I can say is that IDDOV, the Taguchi method, the MTS, and so on, is in line with the Industry 4.0 because we can fusion, for example, to get the voice of customer in the real time. So it will enhance the IDDOV when we fusion that with the Industry 4.0, with the data analytics. Because we don't have to spend more time to do the voice of customer survey. Previously, we have to, for example, if we want to design a Proton car, we want to design a car, we want to design a smartphone, we have to ask the user what they expect for the new model. So now we don't have to. Even surprisingly, when we meet our Asia Pacific Industrial Engineering colleague, myself and Professor Shari, we are the board member for that organization as well. Most of our colleagues in Taiwan, in Korea, China, and Japan, they no longer use survey form to get the survey from the respondent. They use AI. So they are talking about the algorithm, how to, the good algorithm, the best algorithm to give their result. So to answer your question, we are in line with that.
Thank you very much.
Welcome.
I can give considerations.
Thank you.
Thank you.
Okay.
Yeah. Thank you. Please.
I have one question. Like in this bus timing,
Uh,
taken T method.
yes.
What was your response and what was the variable you captured in that?
Okay. Because I don't have the slide here, but what I can remember, the variable is the time that the bus start to move, and then the speed of the bus, and then the weather condition, and then the time of the day, whether it is busy time, off-peak time, and so on. They are among the variables. Okay. Actually, the variables is similar to the variables that we use for prediction, bus prediction or traveling time prediction in industrial engineering. But it's just that when we have lot of data, then we instill with the algorithm, we can use that for prediction.
Okay, any more question?
I will, one comment.
Yeah, yeah,
Yep.
please.
Should I use microphones? Just a comment and kind of make a long point that okay, I was very interested when you mentioned the predicting future voice of customer.
Yeah.
It's very difficult to do. Right now, only way I know is to have a dialogue with customer and asking question why. You know, or whatever they say, you ask why. Why do you say that? Why do you say that? You know, that's the only way I know. You know, then we think about what is that hidden voice? What is that hidden wants and need? You know, then we want to detect that, discover. But so you're suggesting to use T method to predict future voice of customer?
Together with the artificial intelligence algorithm.
I would love to see a case study,
Yeah,
but
inshallah.
you don't have case study yet.
Yeah.
Because bus, I mean, you know, it's not necessarily voice of customer.
Mhm.
So in ICRQE, maybe in future, you know, we develop a way to predict future voice of customer using T method. That'd be
Yeah.
great.
Yeah.
So that will be my comment.
Yeah. Thank you. I think that's doable if we can integrate that T method with the natural language processing. I think that's good topic. But for your information, inshallah, there is one PhD student coming in. Our work is going to do the real-time classification for the dates fruit. In Malay, we call it buah kurma, dates fruit. We want to classify whether it is good date and bad date for the classification. We want to use a real time. Currently, what we are doing is we use the data set, but now we want to integrate with the IoT, Internet of Things. That's one of the cyber physical system, the Industry 4.0. Pardon?
All these are AI marks, right?
Yes.
Very, project.
Yeah, that's the ongoing process. But currently, at least we can increase the mean absolute error is good enough. Yes, it's quite challenging. So before I end my presentation, I would like to share with you that there is an intention by our colleague in Malaysia to establish maybe we will discuss the name of the society. Maybe we are going to have the online meeting after this. We want to establish something like Taguchi Quality Engineering Society, or if the register of society allow us to use center, maybe we can use Taguchi Center, Taguchi Quality Center as their society name. So we are going to have, we are going to establish that center in Malaysia, and we appreciate is our colleague from abroad to become our member in the future once the society is established. With that, I end my presentation. Thank you very much for your participation.
Okay, thank you to Prof. Salamus Dr. Fayorita for the speech. Okay, so
Sensei aku dah lain muka. Tok
session.
guru dah lain muka.
Good. Hiện tại Prof. Miyagi Sensei will give the certificate to Prof. Rijal. About C square. No.
So, okay, so for thanks a lot. So,
Yeah, thank you. Okay, doa ada kata doa mas.
that's great.
Oh, have another one. Okay, thank you. Yeah. Thank you. Thank you. What? Yeah, aku boleh.
Okay.
Sana kan?
This
Just moderate only. The timekeeper tak ada? The timekeeper tak ada? Nanti ada eh? But 5 minutes or 5 minutes, okay? Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. So today I will moderate our second parallel session. Just to note before we start, I think every presenter will be given 12 minutes for presentation and 3 minutes for Q&A, just to keep our time accordingly. We have our timekeeper and we'll alert you when the 12 minutes comes. So to make sure that you try to, you can wrap up your presentation, okay? So without any further ado, I would like to call upon our first presenter, Mr. K. Arun Kumar, with his presentation title, Establish and Optimize T6 Heat Treatment Process for High Pressure Die Casting Parts. Please welcome. Jaga time ya. Jaga time tak? Jaga time tak?
Good morning, everyone. From TVS Sundaram Limited, India. So I'm going to present my project. My project title is Establish and Optimize T6 Heat Treatment Process for High Pressure Die Casting Parts. So before going into my project, I would like to briefly give a introduction about my company. So our company is Sundaram Clayton Limited. SCL is a major supplier of aluminum die casting components to global automotive players, and SCL seeks to provide full ranges of service in aluminum die casting under one roof. We also have a complete range of die casting processes such as HPDC, LPDC, GDC, including machining. So if you see the sales, our new target is we are planning to target close to 3,200 crores. So our core business is basically supplying the aluminum components to commercial vehicles, passenger cars, and two-wheelers. We are also into the strategic business for EV and the structural applications. So a few of our products are given below. Okay, so to get started with, I would like to give the definition of high pressure die casting process. So the image, the left image shows the. So this image shows the schematic of a high pressure die casting process. So where you could see the molten metal is transferred from the ladle into the short sleeve. Then this plunger pushes this molten metal with high pressure and high velocity. So what happens is this molten metal will be forced into this die cavity and it will form as the casting. So after solidification happens, this ejector platen will get opened and the castings will be ejected. So this process is called high pressure die casting process. So what are all the characteristics? If you see the first one, we could able to produce complex, intricate, and thin geometries up to 2.5 mm. And also it has higher productivity due to its rapid solidification. So you could see the cycle time ranges between 50 to 120 seconds. And also we could able to produce components with tight tolerances with the excellent repeatability. Coming to its drawback, because of its high speed injection, it creates a turbulent flow which can lead to more internal porosity. A few examples of the components made from this process. So what is the problem statement? Currently, customer has increased the requirement of mechanical properties as shown in the table. You could see the existing requirements of UTS, yield strength, and elongation are revised as shown in this new requirements column. The problem here is these existing requirements can be feasible in T5 heat treatment process, but the new requirement is not feasible. So there is a need to go for the next level of heat treatment process, that is T6 heat treatment process. So our problem statement is unable to meet the current new requirements of mechanical properties with the T5 heat treatment process. So what is the benefit? It gives the potential for SEL to secure more business and benefits of lightweighting by reducing the wall thickness of the existing product, and we could able to get gain the expertise in the development of structural parts. The last point is improving the customer satisfaction and confidence. So our theme is to establish and optimize T6 heat treatment process for high pressure die casting parts. So the target we have taken the new requirements which are specified by the customer are taken as the target for this project. So this is the Gantt chart of the project, so which includes all the list of activities against this timeline. So the next phase is the observation phase. So here alloy selection plays a major role. So what we have done is by looking at the DIN standard, the alloy is selected based on higher mechanical properties. So the alloy selected is ENAC 43500, that is ALSI 10 mgmn alloy. So here, if you see at SEL, currently we are manufacturing a component. You could see this is a structural member connecting between this wheel and the suspension. So this component is already uses this alloy. So we have taken this casting for our analysis. So if you see the mechanical properties comparison, this is the requirement specified by the customer, which is highlighted in the gray bars. But if you see the actual results, which are slightly above the current requirements. But if you are comparing these actual results with the new requirements, still there is a gap. So this tells the requirement of T6 heat treatment process. So what are the benchmarked values? So through literature survey, you could see here this T6 heat treatment process is the one where you could see higher mechanical properties with reasonable elongation. So we have taken this heat treatment process, and these maximum possible values are also benchmarked using this standard. So what is the challenge in T6 heat treatment process? If you see the process difference, T6 between T5 and T6, T5 heat treatment is the one where the castings are heated to lower temperature, say 150 to 200 degrees centigrade, and it will be held for 2-5 hours. Whereas in T6 heat treatment process, it has 3 processes. One is solutionizing, then quenching, followed by artificial aging. The solutionizing means the castings will be heated to very high temperature, near to solidus. then it will be quenched immediately in the water, then followed by the same process. So what happens because of adding these two processes, when we are heating the casting to higher temperature, so as I explained in the problem statement, HPDC castings are having more internal porosity. So when you are heating to a higher temperature, this internal porosity will expand and it will come to the surface and forms as a blisters. You could see this kind of defect will come when we are going for T6 heat treatment. So we have to keep in mind that while doing this experiment, we should end up with higher mechanical properties with no blisters in the casting. So we have taken the 8 steps robust optimization using Taguchi method. So what is the scope of this project? If you see, this is the complete process flow of a casting process. So here our scope is only limited to this heat treatment process. So we have defined the scope. So parameters, in-scope parameters are heat treatment parameters, die casting parameters, whereas outscope is controlled, we cannot change. So the chemical composition, casting geometry, tensile preparation methods, they are all in outscope. So we're coming to methodology, instead of testing the complete casting, what we have done is, we have taken a cut sample from a casting and we have performed the heat treatment in a small muffle furnace that is in a laboratory setup. So step 2 is identifying the ideal function. So based on the literature survey, you could see there is a strong relation between the mechanical properties and the wall thickness of the component. So wall thickness is taken as the input signal. So in the selected cut sample, there are two regions of wall thickness. One is 4 mm wall thickness at the top and 6 mm wall thickness at the bottom. So this is because of providing draft in the casting. So if you are checking the mechanical properties between these two zones, M2 is having lower mechanical properties than M1. So Y is inversely proportional to M. So coming to noise strategy, we have taken 3 noise factors: casting position, variation of die temperature, and variation of quenching water temperature. We have also done preliminary noise study. So based on these plots, noise factors are compounded as shown in this table with, based on high response and low response. So selection of control factors. So we also constructed the P diagram. So in which you could see we have selected around 7 control factors. So in this, we want to monitor solutionizing temperature because this contributes to the blister. So we have taken the another version of L18, that is 6 power 1 into 3 power 6. This L18 is selected. So totally we have conducted around 72 experiments and the results are presented here. So while doing the analysis, we understand that the correlation between the input signal and the response is not consistent and the results were not satisfactory. So it was advised us to use the WNTP method. So this is the equation which we use. So coming to raw data analysis, this is one way of representing the raw data plot. Here you could see that experiment number 9 is having less variations within M1 and also less variation within M2. So that is why it is showing higher Ascent ratio of 28.9. So the raw data plot is also presented in another way. Here you could see the consistency of noise effect. So between N1 and N2, you could see always N2 is having higher mechanical properties, and between L and R, there is an inconsistent between the results. So based on the calculation, we also plotted the Ascent ratio and mean for yield strength and UTS. So here you could see the optimum parameters are selected based on these graphs. When it comes to elongation plot, the pattern is completely different. It is opposite to the strength. So there is a need for us to select a different set of parameters for elongation. So totally we have selected 2 parameters. One is for UTS and yield strength, and another one is for elongation. So based on the optimum parameters, we have conducted the experiments and prediction and confirmation also done. So between prediction and you could see that against 5 dB we could able to get 6 dB, and for yield strength against 3.7 we could able to get the dB of 5.08. So the reproducibility is acceptable. And also the mean is improved by 27%, and here you could see it is improved by 41%. with respect to elongation, these parameters derived from the strength plot already yielded the required elongation values. So we didn't use the elongation optimal parameters. Suppose the requirement is the only elongation, then we can go for that second level of parameters. Okay, so these mechanical properties were compared against the benchmarking value. You could see the values are within the benchmarked limits. So these plots are also done in another way. Like here, you could see that the variation between initial and optimum, the variation you could see it is reduced and the mean is also improved drastically. So what are the benefits? So it will give potential for securing more business, especially in conversion from stamping, forging, steel extrusion parts to HPDC castings, and benefits of lightweighting. And we can also reduce the product cost substantially. Intangible benefits are customer satisfaction and confidence. Technical knowledge also can be acquired. And the one more aspect is the thermal conductivity of the casting can also be increased up to 60%. So it gives almost potential of getting business worth 9 crore per year. So what are the lessons learned? So most influenced factors affecting the heat treatment process are identified this robust optimization process. That double NTB method, which is a new method which we learned, is an effective method if there is no known relation between the input signal and the response. Noise study, yeah. Noise strategy and preliminary noise study are very important steps for robust optimization. So the next steps are this study can be extended to validate the optimum parameters for the complete casting. And to increase the mechanical properties further, we can also use high level vacuum and also cast tensile bar. So the distortion on account of casting also we have to validate. So with that, I am completing my presentation. Open for questions.
All right, thank you, Mr. Howard. Now I open the session for Q&A. Any question from the floor?
NTB means nominal limit, right?
Sorry, sir.
NTB is nominal limit.
Yes, nominal.
What is double NTB?
Yeah. So this NTB within M1 and the NTB within M2. So we are calculating basically 2 NTB between M1 and M2. So that is why it is termed as double NTB.
Combining signals.
Yes. Normally, if you see the results of M1 have linear with respect to M2. So that the relation is normally linear, but here there is no correlation. So after this study, we understand since there is no correlation, we have gone to this double NTB method.
Similar to what fluid dynamics.
Yes.
Any other question? Yeah, Rosetta.
Just basic one, because the nominal the best started as a but not very see but the considered as static quality of stage.
Sorry, I didn't.
Sorry. Okay, just a very basic understanding because we know that when you're showing the orthogonal just now, it is directly linked dynamic FDR because you have a signal factor even in 1 and 2 and 3, right? Okay. Yeah. Dynamic
Response. Yes.
but why you still put the NTB in the dynamic static resolution?
Okay.
Why the name is including both dynamic and static?
See, before start of this project, we thought that the wall thickness is contributing to strength based on the literature survey. But we are doing different kinds of heat treatment. So the heat treatment process is not constant for all L18. So because of the change in process, the results what we thought like always casting wall thickness will improve the mechanical properties. This direct relation is affected. So after this study only we came to know that so there is no strong relation between wall thickness and the output response.
Okay.
Yeah.
Because it's a weak relationship.
Yes.
Yeah. Shin Sensei. Shin Sensei. Yeah. Oh, okay.
I'm just wondering, posing now because casting wall thickness, how do you put with the imaging input for the
Okay. So basically, if you see the wall thickness contributes to the mechanical properties, how it is being like if you have less wall thickness in PDC, the rapid solidification, because of rapid solidification, high you could see small dendrites. Whereas if you are going for high wall thickness, the dendrite size will be somewhat bigger. So the mechanical properties of a component is normally depends on the dendrite size. It is directly proportional to the dendrite size. So if you have very small dendrites, you will get higher mechanical properties. If you have a large dendrites, you will have lower mechanical properties.
But your dendrite will reduce the
Strength, yes. This is PDC. If you go for GDC, gravity die casting, normally the solidification time is not little big, because the solidification time 100 seconds, 150 seconds. So there the dendrites will be very long. So there you cannot get these mechanical properties. But in PDC, the solidification time is 10 to 20 seconds. So that is why we are getting higher mechanical properties in HPDC. Even in that, between this wall thickness, there is a change in the shape of the dendrites.
Okay, let me make some comment. Can you go to the diagram? You know, since I coached this project, I feel responsible for it, for the confusion. The wall thickness can be input signal for the solidification time, right? But in this case, wall thickness it should be classified as indicative.
Okay.
Indicative part.
Okay.
And because can you go to the low data part, LAT? Yeah, this one. Like for example, look at number 9, the very high signal to noise ratio, right?
Yes.
So difference between 4 millimeter and 6 centimeter or millimeter, whatever,
Millimeter.
1 and 2, right? It's not a noise effect. It's not even signal effect. It's an indicative factor. We know the mean will be different. So in the signal to noise ratio, the effect on the mean, the difference between M1 and M2 is not included in the noise variance. Noise variance within M1, noise variance within M2 are averaged. That's the noise variance. Meaning, because noise variance is within M1 and within M2. The numerator is a mean. So that's how we deal with indicative factor. Indicative factor means it's not control factor, it's not noise factor. We know the difference is there, but the difference is not noise effect. Therefore, in noise variance, you don't include that. I see lots of questions.
Yeah.
Okay. So, oh, sorry about that. Yeah, here you go. Where's the like?
This one.
Oh, this one. Okay. So variance within this plus variance within this is the noise, right? Because there's M1 and M2. With difference between these two is not a noise. So signal to noise ratio is overall mean divided by variance within M1. So that's why it's called double nominal best. And my father may say, you know, Shakespeare wrong, but who knows, right? So, and you know, I think it's a. I wish we had good dynamic response for die casting, and we are still looking for good dynamic, dynamic ideal function. So that's what it is. So I hope it made it some clear. But it's obvious, right? It's obvious that this is high signal to noise ratio. This is very low ascent. You know. So I'm sure this project gave lots of good, robust technical knowledge. So I appreciate the hard work. Thank you. It's a physical test, right? No simulation. So
It's a physical.
All right. With that, thank you very much,
Thank you.
Mr. Aaron. Let's give a round of applause to Mr. Aaron for his presentation. Okay, next I would like to call upon our second presenter, Ms. Yong Huan Chow, with her presentation title, Enhancing Feature Selection in Mahalanobis Technology System Using Binary Whale Optimization Algorithm. Without further ado, please welcome.
Can I have a pointer? Okay, selamat pagi semua. Good morning. Ohayo gozaimasu. And please forgive me, I don't know in Tamil, so maybe gentlemen can teach me later. So I'm Chao. Today I wish to sharing on enhanced feature selection in Mahalanobis strategy system using binary wheels optimization algorithms. And can I have the pointer, please?
Pointer is
So I think over here, all of us here mainly know what is MDS. So it consists of MD and Taguchi methods. For MD, it is a measurement to measure the abnormalities. And Taguchi method is using the OA and SNR to select the significance features. So there is some challenge on OA, saying that OA is hard to handling large value of features, and sometimes it might not generate a good features combinations. So it is proposed to having a new algorithm to replacing the OA. And I would like to introduce on the WOA, the wheel optimization algorithms. So this is an algorithm introduced by Bejalili and mimics the social behavior of humpback whales. There is almost three of the behaviors. First, the humpback whales will search for the prey, and then when they targeted the prey, they will go to encircling them, and then using the buffer net method to hunting the prey. And why are we choosing WOA? It is proven that it has a good exploitation, good exploration, and it has a fast convergence rate. And it also has the ability to escape the local optima. And I'm using the BWOA, which is the binary variance of the WOA, because the classic WOA is only most in continuous space. So I need the binary parts to make the feature selections. And there are few types of BWOA and binary ways. There is S type, V type, Z type, but I'm using the classic one, the S and V. So they are using the different mechanism to transfer the binary. And for the traditional one, the MTS is using the OA. So I'm replacing the OA part with my BWOA. And can Dr. help me to click on the icon? Yes, so can you help me to slideshow? Okay, so for the MTS BWOA, firstly, we filter out the data with the missing value. So we remove it, or those data that is unidentified, we all remove it. And then it goes into the MTS parts where we initialize the population and iterations. For this experiment, I'm using 10 population and 50 iterations. So in the MTS OA, we will generate OA tables, right? But for BWOA, we generate the population tables and it acts like OA. So we're using these tables and we find the SNR. And then after that, we get a best solutions in the SNR. And then we'll go into the WOA algorithms. So in our WOA algorithms, I want to emphasize over here is when we entering it, it will having a higher exploration rate initially and lower exploitation rate. Then after as time passing, as the iteration passing, the exploration rate will be lower and exploitation rate will be higher. So after this, we will get a table with decimal points, but that is not our result because we want it in feature selection. So we need the binary parts, which is sigmoid and hyperbolic tangent transfer function to convert it either in sigmoid or the S shape or V shape. So depends on what we're selecting. And after that, it will convert back into binary values again. And then when the iteration is finished, since like what I'm saying that I'm having a 50 iterations, when all the 50 iteration is finished, we will collect the best result of the feature selection. But that is not the end yet. So can Doctor help me to back to the slide just now? So after that, we will run the MTS BWOA for 30 times. This is a number we selected, but it depends on what we need. Maybe you need a longer time to prove it or smaller time because you think the result is good enough. But for me, I'm using a 30 times to run. If the feature selected, the features is having exceed half of the experimental run, then it means that these features is good enough and it will be selected. If it is less, then it will be eliminated. And this is one of my results from the benchmark dataset, the breast cancer Wisconsin. So I'm getting the MTS BWOA S and B, selecting the features 2, 6, and 8, like I'm explaining how it select before. And we can see it from over here, the MTS BWOA S and B is having a higher feature reduction rate than MTF. So although it is having the same with MTS BSO, but I would like to say that BWOA, the WOA is having an advantage than PSO because PSO is having two variables each time when it updates the positions, but WOA only using one. So it is less in the memory space. And also BWOA is having a higher exploration rate than the PSO part. Then for the system gain, we can see that MTS BWOA S and B is getting a higher SNR gain than the MTS. So for the convergence rate wise, we can see that the MTS BWOAS is having a faster convergence rate, but this is actually very dependent on the initial population's value because we generate it in random. Sometimes it will having a better answer when it achieves the convergence. And this is the discriminant ability for breast cancer Wisconsin case. The MTS doesn't look very nice for the origin compared to the original one because it still looks very close for the healthy and unhealthy sample. But for MTS BWOA, it shows a clearer discriminant. So in conclusion, the MTS BWOA S and B is outperform MTS, and MTS BWOA S and B still seeing some similar outcome for feature selection, but the S is having a faster convergence. And in future, maybe some of you already realize I doesn't mention on the accuracy part because this is the classification aspect. And I think that if we play with different method, it will get a different accuracy value. But in this this present, I wish to emphasize on the feature selection part only. And maybe in future, we can try on different type of transfer function or different type of data set. Because now I'm using only the features with 9 and 600 something data set. So maybe we can try with a very huge number of features or etc. So that's all for my presentations. And any questions for me?
Yeah, thank you, Miss Wong. Any question from the floor? Yeah, please.
I just wanted to know what is
Okay, this conversion. So because I'm saying there is a 50 iterations, so each time the MTS BWOA runs, it will goes and then it will not achieve the best SNR, the best objective function yet. So this is the convergence when it achieves the best objective function.
So can I say
Mm,
iterations?
yeah. Yes. It depends. So as I say, it depends. It depends on maybe the populations. If you put it a more higher value of populations, then it will having maybe less iteration.
Your research is primarily focusing on MPS along with other algorithms, right?
Okay, sorry. Pardon?
Only on MPS
Yeah.
with the PWA.
Yeah, I'm focusing on replacing OA with a new algorithm.
Focusing on dimensional direction.
Yeah.
Have you tried other algorithms like in conjunction with dimensional reduction? Maybe MPS plus this will give some accuracy. Maybe artificial neural networks. I'm just making an example. Plus, same is the different type of features.
Maybe.
Maybe other side, artificial intelligence instead of MTS plus BWOA may give better result. I don't know.
Yeah. Maybe we can do it in the future world.
Yeah, correct.
But right now you are focusing on MTS and the feature.
Yeah, correct. So like yesterday I seen many experts sharing your works. So when you using the OA, maybe you can consider by using this MPS BWOA, and it might generate a better result. Thank
Any
you.
other question? Yeah,
I have
please answer.
one question or comment. So, yeah, thank you for the presentation. And I think it's great that at the end of the day, you want to maximize the discrimination. That's for sure. So that's great. I do have a question here. Can you define future reduction rate?
Feature reduction rate, is
Yeah,
it?
what is that?
Okay, this is the total features
Mhm.
divide by the features reduced divides by the total features.
The features are the variables,
Yeah.
the MPS variables.
Yeah.
So how much you reduce the number of the variables?
Yeah, so means like
So more variables you take out.
Yeah.
Higher rate of the
reduction.
eyes.
Right.
So is this better? Are you saying it's smaller the better or larger the better?
It's smaller the better. Of course, it's smaller the better because we're having a smaller features we are enhancing.
It seems like whatever the reduction rate, as long as it maximizes the discrimination, that's a good system. Right?
Yeah.
Okay, I have to think about it. Thank you.
The goal should be improve the accuracy of prediction. You may have more than.
Yeah. Maybe I wish to talk something more because in this time I'm using the SNR as my objective function. But if you want to use the accuracy, it's also one of the options to do that.
Yeah. Any other question from the floor?
Yes.
Okay, if not, then thank you, Ms. Wong, for your presentation. Right, I would like to call upon our third presenter. I would like to call upon Ms. Shah Mudassar Abdul Sattar, Mr. Sharat Singhania, and Mr. D. Dinesh Kumar with their presentation titled Robust Optimization to Eliminate Handlebar Juddering in Scooter Vehicle Using Taguchi Methods. Please welcome.
Hello, good morning. I am Sharat Singhania from TVS Motor Company, and with me my colleague Mr. Sheikh Mudassar. We are going to present today on robust optimization to eliminate handlebar juddering in scooter vehicles. I'll basically take you through what is the problem in upcoming slides. Before that, I would like to introduce about TVS Group. TVS Group founded in 1911, and with exceeding business 8.5 billion USD. We have total 100 companies and employs more than 60,000 people. And this is the overall journey. We started with bus service and then gone to automotive component manufacturing. Then we had tie-up with Suzuki, and then we started our two-wheeler journey to moped, and now we have various collaboration with companies like BMW, Norton, and couple of EV companies. And we have, I think we are the one company in India who has a product in every category for the customers, includes moped, scooters, and motorcycles. So coming back to the problem, like in scooter vehicle in general, we have juttering field, which we are calling a rhythmic oscillation of about 15 to 30 hertz. Happens at 50-60 kmph usually. So this happens on a plain road when a rider goes on a flat road with small disturbance. The road input energy, which basically it reaches to a natural frequency of the overall system, and it creates a rhythmic oscillation at the handlebar, which felt by an expert rider, and especially those who ride quite often in the company as a problem. It is a function of basically motor frequency, which is vehicle geometry and structural stiffness and other subsystem property dependent. And so these are basically scooter vehicles are primary mode of transportation in India, and this problem, if we improve, will definitely enhance the ride quality performance and superior joy of ride experience for the customer. We had this problem reported, not this, but in general, vibration problem reported in, can you go back to the previous slide? Yeah. So vibration problem reported in some JD Power survey, especially for the scooter vehicle. Yeah, maybe next slide. So from our internal observation, we found that I'll just try to point. Yeah. So when we have taken some objective measurements in factory, and we found that this vibration field is about 4 to 6 in that range, compared to the target of 8 out of 10. And even the handlebar acceleration PhD plot showed that we are about we are considerably higher in terms of accelerations compared to the target and competitors. And in scooter front ride comfort problem, we observed that about 60% problems are because of juttering feel and harsh feel. So to resolve this problem, we have taken 8 steps of robust optimization. I'll be taking you through each steps in coming slides. So first is like we have defined the scope and ideal function for the for solving the problem. So in scope, we have taken chassis subsystems. We have taken the chassis subsystems, including suspension, tire, frame, and toggling stiffnesses. And out of scope is seat, wheels, road surfaces, vehicle speed, and engine. So basically, we try to solve this problem irrespective of engine, because our colleagues in other teams are anyway working to resolve engine vibration related transmissibility to the handlebar. We are trying to complement to the chassis systems. And we have an input signal as a road disturbances, and output is a reduced energy, basically the difference between the road energy and the handlebar energy. We have taken front and rear suspension stiffnesses and damping as a control factor, and frame and toggle link structural stiffnesses, and toggle link stiffness, tires, stiffness and damping. And variations in this control factors we have taken as the noise factors. we have conducted input signal studies because we also wanted to capture which road conditions create this problem and what is the input energy from the road. And out of that, we selected these three input as a. So this is the final load conditions we arrived at, that it happens around 50 kmph, especially on highways with patches, and we have taken Belgian pave also as a dynamic system response study, and this various load conditions for the study. So these are our control factors, 8 control factors, and noise levels we decided based on the variations, basically production variations and aging. We have 8 control factors, 3 levels for the study. And we have used the sliding mode for rear suspension and front suspension because we don't want the vehicle stance to change. If you make front too soft, the rear will be hard and the stance of the bike will change. So this is the sliding level we have used for front and rear suspension. So this is how the rear suspension levels are changing with front suspension stiffnesses. So in total, we have conducted L36 DOV metrics and 864 simulations run. And we found that there are 2 critical parameters which could provide the solution, basically front suspension stiffness and tire stiffnesses. And basically, yeah, and we could gain about 16 dB gain during the prediction, and we could confirm about 14.64, significant variability reduction, which we could capture during the verification phase, that there are 30% drop in the handlebar acceleration. So in conclusion, we got a 14.64 dB gain was confirmed, and we could increase the energy absorption by 150%. And we found 2 critical parameters from this study, because this problem is more subjectively felt, and there are so many parameters which were involved, contributing to this. We could converse to 2 critical parameters, which was a good result. And we have implemented this in recent NPD project. And we are looking forward to implement this simulation methodology to all our new products, especially for scooter type vehicles. Yeah, thank you. Thank you so much.
All right. Thank you, Mr. Sharat. I open the floor for any question. Yeah, Dr. Prof. Rijal.
Can I spot the non-factor? You show in the slide diagram. Okay.
Sorry. Signal, this one? Noise level?
Noise factor, right? Okay.
P diagram. Okay, sorry. Yeah.
Okay. Why you didn't include the road surface as your noise factor? Because I wonder the different type of surface, road surface will affect
Yeah.
the gathering problem as well.
Yeah, this whole project was done as part of simulation, where the vehicle was not there, but we built the multi-body dynamics and we did the simulation. In that simulation, we have done, taken input signals at different road conditions. So the input itself was given at the different road conditions, and that road condition is not the noise; it's an input, because it's an indicative factor for the energy to go into the system. The road conditions. If the road condition is very bad, the energy goes into the vehicle is high. Versus the road condition is very flat, the energy that goes to the vehicle is low. So these were considered as an input itself. So input, we have given multiple signals to this system. And since we did this as a simulation, the variation in the control factors are considered as well noise factors because there is no environmental conditions or other factors we can put it in the simulation.
Yeah, but in the real practice, I believe the road condition should be the noise factor because we don't want the handle to judge at whatever road condition.
Yeah. So if you go back to our slide, there are three road conditions we have considered: the plain, highway with patches, and this Belgian paving. So Belgian paving is more of rough surface, and there are payloads like solo, duals, maybe 1% city, 2% city. We made this matrix, and we saw overall there are 12 conditions of the road, and then including the payloads. Out of that, we have selected these three conditions, and when we run the simulation, we have run the simulation for these, and these. So already road conditions are considered as the input to energy to the system.
Load condition is equal zero. Because depending on load condition, the force from a load is different. The function is to observe that energy so that it doesn't transfer to the hardware to the driver. So input signal. And because of the simulation, right? Variability of control factor is the best way to induce effective noise. Because the simulation itself doesn't have any noise factor in it. It's a 1D simulation, right? And you did this sliding level. So I do think it's a very, very, I shouldn't say that, right? Because I coached them. But yeah, very good.
Yeah, any other question from the floor?
I think the road condition is something that is 389, right? Not 370, 372.
See, these are the energy levels in the different conditions. Now we got around 12 conditions: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of that, we have taken one M1, M2, and M3.
Yeah, M3, I think you put 3.
Yeah, you're right. Yeah.
Okay. Yes. Yeah. I think this highlight was supposed to be done for the maximum, so maybe this has. Yeah. Otherwise, the values are right.
I was politely pointing.
Sure. Thank you.
Any other questions? We got, I think, around 2 more minutes for this presentation. Dr. Rosetta, any question? Anybody? Okay, with that, thank you very much, Mr. Singh Mudasa and Mr. Sharat,
Thank you
for your presentation. So next, I would like to call upon our second last presenter. Okay, I would like to call upon Mr. Dinesh Kumar, Mr. P. Bhaskar, and Mr. K. Srikant for their presentation title, Robust Design Optimization of Scooter Engine Combustion and Convention System Functionality. Please welcome.
Good morning. Myself, Bhaskar, my colleagues Srikant and Dinesh. Good morning again. We'll be discussing on robust optimization of scooter engine combustion and conversion system functionality. So I will skip it. Already introduction done. Only one information I want to add. We have engine capacities, various capacities from 100 cc to 310 cc products. This research work is particular to one scooter engine. See, generally the ICE engine, internal combustion engine, takes air fuel mixture inside and combustion happens. and the products are exhausted waste gases. The ideal the ideal is complete combustion. So CO2 and H2O will come out, but there are limitations in heat engine. So it has some incomplete combustion happens. So hydrocarbon, HC, carbon monoxide, CO, and nitrogen oxides, NOx, methane also possible to go out of the environment. So the government puts a lot of restriction in terms of regulations. This graph indicates how the Indian government, the BS Bharat standard, gone from 3. The first line is 3, BS3, BS4, BS6. We are not gone into BS5. Our government has taken a stand to go directly from BS4 to BS6. So the norms regulation are stringent. 80% reduction is demanded from previous standard. So with this background, yeah. So with this background, our work is on two areas. One is on combustion, another one is conversion. Combustion basically it takes intake air and fuel, and fuel is injected through this intake manifold, and combustion happens, and the gases are exhausted. This is called this area is combustion, and then the exhaust gas is going to some treatment, the catalytic converter, three-way catalytic converter, where the incombustible gases are converted into some of the harmless gases. So our work involves in both area. Of course, naturally, this reduced pollution will help for society and enhancing human life. With this, I hand over to Srikanth. Yeah.
Yeah, good morning. We'll go through the problem. See, vehicle emissions, namely carbon monoxide, hydrocarbons, and nitric oxides, will be harmful for the environment. Hence, government puts a lot of regulation on this. Here we have a regulation limit. That's what is mentioned. Sorry. Okay. Here we have a regulation limit. What I mentioned in the red line, it is for hydrocarbons. Internally in our company, we follow our internal regulation limit, that is lesser than regulation limit. We take this as an internal regulation limit to monitor our product performance month on month. Our production vehicles will be picked up. Yeah, sorry. This is our production sample data. Here we could see we are going closer to the internal regulation limit. This is a problem we have noticed, and we have taken this as a problem to address through robust assessment project, robust optimization project. Here, if we see like this, we have tracing for all the pollutants. Suppose if these pollutants are not meeting the regulation limits, we have a potential risk of stoppage of production, and also sales loss will be there. And also it has a environment impact. Then we have taken a T1 target to reduce emissions by 20% from the current level. That is the target we have taken. This is a step methodology we have followed for robust optimization through using Taguchi methods. We'll go one by one. This is the scope from the combustion system. We have taken in scope is engines, fuel, and induction system, and from the software side, electronic control unit, that is ECU, we consider for optimization. Then under this in scope, we have taken selected the parts. One is pipe intake, and second one is engine control unit, ECU. And outscope is other than engine system, like injection and exhaust system is considered in the outscope. And under conversion system, that is exhaust system, we are considered as the in scope. Under exhaust system, we have a muffler, catalytic converter, noble metal. Catalytic converter, we have a noble metal ratio. Okay, this is a muffler. Okay, here this is the place where we have a catalytic converter is placed. Engine out emissions will be passing over the catalytic converter. It converts the harmful gases into stable products, which will be safer for the environment. This is a body muffler. Here it reduces the sound of the engine. And outscope we have considered engine system and software. Under software we have taken a control systems engine ECU. This is the ideal function under combustion system. Combustion is the transformation of chemical energy into mechanical energy efficiently. Here efficiently we have mentioned here because if it is conversion is happening efficiently, then we should have a lesser emissions. But it is an ideal condition. It is not possible to have a complete combustion. Hence we have a emissions. In this case, here I want to specify one thing. When engine is in cold condition, uh, it has a higher friction. To overcome the friction, engine develops a lot of emissions. In cold condition, emission levels will be higher. In hot condition, there is a chance that nitric oxide will be higher in level. Hence, we need to focus on cold emissions as well as hot emissions. Coming to conversion system, here conversion is conversion of harmful gases to non-harmful gases, that is stable combustion gases. Here, potential causes for the emissions are noble metal loading and gas flow restrictions are the main causes for the emissions. If you see here, this is the intake system in which injector is mounted. The injector replacement plays a critical role also, and spark plug initiate the spark and for the combustion. Then once combustion is happened, the combustion gases pass through the catalytic converter. There, harmful gases will be converted into pollution-free gases. This is what here we mentioned. Injector position is important, and catalytic converter noble metal loading is important for the emission to control. This is how we measure the emissions in our laboratory. This is a WMTC cycle which we are using for emission measurement. This consists of 1200 cycles, 1200 seconds testing time, in which 600 seconds called as a cold phase, wherein cold condition emissions will be monitored. Later, the 600 seconds is called hot phase, where hot condition emissions will be monitored. Both are important for emission control. This is the P diagram. Under combustion system, the response is engine out emissions here lower the better is better for combustion system. Here noise conditions, as I mentioned, the cold condition emissions will be higher, and not hot condition also. Other pollutants will be higher. Hence, these are considered the noise factors. And from the control factors, we have considered ignition timing, fuel injection angle is considered as a control factors under hardware control. This is software control. And under hardware control, we have taken fuel injection height as well as fuel injection angle is considered as a hardware control factors. Coming to conversion system, here input signal is engine out emissions. Output signal is conversion emissions from the after conversion system is output signal. Here output signal is lower the better is considered. And noise factors here are pipe diameter, flange diameter, and engine out emissions. Here control factors are pre-catalytic converter loading, post-catalytic converter loading, and for the third one is the noble metal ratio. and that is for pre and post, as well as cat position is also considered one factor where we did not consider as a control factor since it has a design limitations. This is the control factors and levels. This ignition timing and ignition angle is level 2 is at a current level. We have taken 3 levels. One is level 1 is lower than the current operating level, higher than current operating level. Level 3 is lower than current operating levels as considered. And then ignition position, that is hardware control. So ignition position and injector position and injector angle is considered at 2 levels. Level 1 is the existing level. Level 2 is the modification we have considered for this study. And noise factors is cold phase emissions and hard condition emissions are considered. And from the conversion point of view, we have taken level 1 is existing level, level 2 is a modified level. And noise strategy, noise factor is here. We have done a preliminary noise study considering the pipe diameter, flange diameter. Okay, here, okay, the preliminary noise study was done. Here we have considered minimum level noise condition, maximum noise condition was considered. We have taken this inputs for further experimentation.
Yeah, next from here we arrived for the combustion and conversion for the other array where we used for internal like inner and outer area we used for the combustion system, where we are going to study on the software versus hardware interaction effect. The conversion we used for hardware with respect to variation of noise. For a combustion L9 we are used, for conversion L8 table we are used. Yeah, as a main effect analysis we are done for the combustion system. With respect to modified level, we are able to A and B and C factor, which we resulted for 2.5 dB gain, where almost from the best level to we reached 2.1. Similar way conversion we did the main effect analysis there, where the modified level of A, B, and C is given result of 0.67 dB gain, and remaining was the existing level maintained. The similar way we mean effect also we analyzed, where we studied in the combustion system. Normally we will able to see the impact on the mean as well as for norm, where we analyzed on the software hardware, which given the significant result of mean effect also, like 89 milligram reduced in the combustion of NMXC as an all 69 milligram is reduced, dB gain of 1.9. Coming to conversion system as a tailpipe, where we are able to see this was 3 milligram reduction in the mean effect. It's a effect of with include of the combustion system. Where the similarly NOx also able to see 1 milligram reduction. The dB gain of NOx we are not seeing the margin. It's only marginal increase we have affected. From here we confirm for the confirmation trial we did. With respect to the confirmation trial, the prediction was 2.1, where our confirmation trial was done dB gain by 1.2. As a mean also we have seen 89 milligram to 42 milligram. The combustion similar to conversion, we are able to see as a mean effect was 3 milligram to 2 milligram, and as a dB gain from 0.67 to 0.4, it's a marginal increase. From what the action points we updated to was in the software program as well as hardware, what we have changed, we updated in the revised drawing as well as supplier check sheet we updated. With this result, we are able to see our factor of safety we are improved like 50%, where earlier we was operating as a 80% from the regulatory norms, where we moved to 50% with a very good margin with respect to regulatory norms. Yeah, this is the okay the lesson and the benefits what we are seeing. The from like the phase on like combustion we are able to reduce 10% reduction as a tailpipe. With respect to phase 2 as a conversion, we are able to see 8%. The cumulative, we reduced 18% reduction as a tailpipe, like it's converted emission we are able to reduce, which significant contribution with respect to regulatory norms, 50% of factorized safety improved. With this optimization, we are able to save even the noble metric order is a potential benefit, and we have saved almost cat loading cost was 90 rupees per the vehicle. Next. As a lesson learning, I just want summary. Again, the vehicle cost we are able to see 90 rupees per the vehicle reduced, and the overall per annum was 16.2 lakhs. And the potential was we updated our learning into the next our upcoming models, scooter models. Our tangibles learning was we understand the complete functionality of the system, combustion and conversion,
And the key learning was where we studied for the software versus hardware interaction, which resulted for without affecting side effect of NOx and the NMX was optimized. And we not seen any performance drop of mileage as well as a drivability. As indicated as a tailpipe emission out 18% we reduced, and we are going to operate 50% of factor of safety, which from the regulatory norms, which will good for the big impact and the business benefits. Thank you.
Thank you very much. Open the floor for any question.
You mentioned about QA score. What is that? On the slides.
QA matrix, sir.
That is something static.
This one, so this is about the action standardization, how the action effectiveness will be there. The QA matrix 5 means which the process consistent will not vary. It's like a okay actions. Yes. Yes.
Internal rating, the level of quality of action. That is the.
If you have a 100% inspection, it will have a QA matrix score 1. Something lower score will be there. If it is automatic inspection method is there, then it will have a higher matrix something. Yeah.
It's like a 1 to 5 rating, sir. The 5 is like okay system where we can't see any changes in the system.
Any other question from the floor? Yeah, she said.
So I think you did like kind of like a full factor.
Yes.
Because not too many control factors. But I think you guys have got pretty good understanding of maximize objective function, which is for O2 to become CO2.
Yes.
So minimize the overreaction to minimize noise.
Yes.
That's what exactly the approach you're taking.
Yes.
Only comment I have is like engine control system is out of scope, right?
Yeah, outdoor area we have to
It's out of scope.
outer, yes.
So maybe more you should move more into taking control factor from engine control system as well.
Okay.
I know it's getting more complicated.
Yes.
But I think in future you should move towards that direction so that you have more drastic equipment.
Yeah, sure. Yeah.
So that will.
Yeah. Thanks, you.
All right, thank you, Sensei. So with that, thank you very much, guys, for your presentation, and please give a round of applause to them.
Yeah, I'm good. Thank you. Thank
you. Okay, last but not least, I would like to call upon our last presenter for around session 2. I would like to call upon Professor Kiichiro Yamamoto with his presentation title, Examination of the Evaluation Results of Machining Conditions during Cemented Carbide Processing. Without further ado, please.
Thank you.
Next.
Next. The next. Back. Okay, good morning. Good morning. I'm Keiichiro Yamamoto from the National Institute of Technology, Toyama College. So in this research is the collaborate with the company, the Noto Alloy, and our students. So I'd like to talk about my presentation theme is the examination of evaluation result of machining conditions during cemented carbide processing. So our past research already to improvement of the cutting process of the cemented carbide. As you may know, the cemented carbide is a very hard metal. So too difficult the processing. So this time try to the grinding process, the finishing process. So we try now currently, so not completely this research, but I want to discuss about the research process. Okay, this is a table of contents of today's present. Okay, next I explain the background of the background and purpose of research. Unquote. So nowadays, the realization of high precision machining is required. The cemented carbide using the forging dies, the customer requires the ultra short delivery time, and the accuracy required the very precision dimensions. So if after the quality check to after processing, so we need to the remanufacturing to begin to start the remanufacturing. So also that is increasing the cost. So we can do the monitoring of the machining conditions during machining is our goals. So the comparison of the evaluation results, monitoring the machining condition. So how do we evaluate is our purpose. So this time experiment, total process electric power proceed weight is a function. So using electricity data. But at first, to easy way. The first analysis is evaluation is roundness. So roundness is we have to check before for the customers. So we have the data. At first, the roundness analysis, but not reproducibility is not good at. So I tried to second analysis. This slide shows the experimental method. This is the CNC vertical grinder. This is the main spindle, table spindle. And this is the cemented carbide test piece. So the diameter is different. And this is tools. So this tool is electrodeposited the diamond tools. So why the difference to measurement of the processing of the grinding is the grinding process is not defined the cut timing. And the grain, the cutting process is the deformation process and cutting process. So, and the main spindle is a so high speed rotation. So because we can so difficult to measurement of the power data. Okay. So this is a control factor. Almost the control factor is machining condition, cutting condition. The levels is disclosed, so company required. Okay, this is the indicating factor. The inside diameter, the difference of the inside diameter and the tool rigidity. Okay, so we measure the first analysis is the roundness. So roundness measuring the in the circle of the full rotation, and open the data. The horizontal axis is the rotation angle, and vertical axis is the amplitude. Okay, and next step. So define the center. So the roundness measurement is the stylus. So you know the stylus, the tracing the inside diameters. So not define the center. The first data is this black line. So this is a waveform. To define the red line is calibration data. Okay, this is the equation on the others. We're using the roundness analysis this formula. Okay. Okay. Okay, the nominal the best response. So this is the result of the response data and the confirmation experiment. So basically, we choose the comparison condition, and the best condition is the after that experiment, 18 the authorization table experiment, but we couldn't using the vertical CNC grinder. So that machine using the manufacturing. So long time to stop. We couldn't stop the grinding machine, right? Yeah. So the result is not good. So reproducibility was not obtained, but the condition chosen by the skilled technicians yield interesting result. So the comparison results, comparison conditions one is choosing the expert engineer. So the confirmation is a little bit good. So, but the roundness is the only measure the whole, not whole process. So just only the inside the one line. The process is volume. Removes the volume. So the roundness measurement is just only the one line of the inside diameter. So we need to evaluation the total electric power analysis. So a regression line was drawn on the machining part of the measurement power data during machining and subtracted from the power data to obtain the integrated power during machining. So this is a power data, the grinding process. This area is a remover, and this is the spark out process. You know, this is a grinding process, the finishing process. So we integrated the power data, this data all integrated minus the regression line, the data, and this function they're using. And the next slide is the electric power equation. This is what we use. And this is the experimental result of electric power response graph. So also the reproducibility SN ratio is not good at, but sensitivity is a little bit good. So from the result of parameter design, the calculations were performed taking the square root due to the dimension relationship. Since the work was evaluated in terms of workload, an improvement effect was observed in the sensitivity. The evaluation of sensitivity was found to be important because we thought that an improvement in processing efficiency would also reduce barrier. So we considered based on the results, a comparison was with the vibration waveform, which was energy data acquired at the same time. Okay, this is a comparison of the vibration data and the electric power data. The sensitivity high is the L17, the condition, and L4 is the poor condition. So you can see the vibration data not defined clearly the difference of the condition, but electric power data, you can find the difference. Okay, so the same conditions, the L17 and the L4, the roundness is clearly find out that difference. So this is a power comparison of the power spectrum. So using the vibration data, so red is a vibration data. So this slide is this axis is the frequency, and this is the time, and the color is the power with the spectrum. So L17 is a good condition, is a almost same data, and L4 is so clearly different. So I found this presentation is the experiments were planned based on the research background and were conducted using parameter design techniques. Roundness and electric power evaluation were evaluated. The result of the SN ratios for the roundness and power evaluations did not confirm the exact additivity of the effects. However, trends were matched for sensitivity, and approximate absolute value matched of the electric power evaluation. The comparison of simultaneously measured vibration data, result of frequency analysis, and power data shows the possibility of monitoring the state of machining while monitoring the state of machining. Okay, thank you.
Thank you very much, Doctor. Now I'll go to the floor for any question, please.
Okay.
Here you have taken nominal the best.
Yes, the first analysis, the roundness analysis, the power analysis, but using the dynamic, like a dynamic analysis. So wait. Yeah. So we get the one data, the one N1 and N2 data, only one data. But the formula is using the
Roundness and the lower the better.
roundness is
Maximum this much.
so higher is the better. So because the variance is low. So roundness, you said the roundness data. Okay. Roundness.
Nominal.
So nominal is the best.
Nominal.
Yes.
It is nominal. So isn't that
No, the distance of the center
distance
of the center through rotation. So this have the 3,000 or 5,000 data. Okay. Okay. So the all point. So this side is angle.
0?
Yeah, yes, that time. But no. The using the diameter is this.
Diameter.
Yes. Not the
Diameter.
the rotation. The all equal is the flat line. Yes.
Roundness.
Yes, roundness is the roundness is this data. We use the open the horizontal lines, the angle, and the vertical lines are the amplitude is the output of the equipment. So the change the distance, but the center is not defined to measure. So it is so difficult. So we calibrated the so this data.
So diameter as a nominal best didn't confirm.
Yes. So because This scale is only 1 micrometer.
Now, when you change to the area on the map, like integration.
Yeah.
So the next one is this one, right?
Yes.
So you integrate, right?
Yes. Yes, energy. All data to integrate. No. So this is Y1 is a beta. Y2 is a beta. We use the
Explode ions.
Okay.
This approach very compound.
Yeah. So just the sensitivity is good.
Yeah. Look at this way.
Yeah. So we need to the more consideration and more analysis is needed. But this is so finishing process. So the measurement is very difficult.
Another question? Yeah, please. Yeah, bro. Yeah. Bro. Okay.
宮城先生。Thank you.
Violence.
Ah.
Cool. So based again, compiled was rounds. So already twice the difference. So why don't you single? Did you already who's the
So you said the y the minus.
sorry? Why?
The absolute value is the difference. Okay. So we consider maybe the equipment error. The measurement equipment error is included the this data and power. Power data have the all machine. So influence is get the power. So panel vibration and the chassis vibration and the spindle vibration. So all influence is including this the power data. So that is so the clearly measurement is could not is this data is show. So we think.
Yeah. Okay. Any other question? Okay. With that, thank you very much, Prof. Please give a big hand.
Thank you very much.
All right. So that will be the end of our session 2. Our next activity will be a morning break. So back I think we're a bit behind schedule. We should start.
次の方が気楽なんです。
Let me
次
stop paper.
でもこんなにこと普通できてないことを発表するって辛いです。これ面白いですよ、これ。これ光るんですよ。でないこと
we can
違います。もうこれ暗くなったら、蓄光体ですね。
while having the same. Thank you. Thank you.
we change to another link. Okay, we change to the another link. Link for the parallel session. Right, sir.